dear viewers, welcome to yet another video on non-destructive testing. In this video we will discuss about magnetic particle testing. Magnetic particle testing is a non-destructive testing to locate surface and subsurface discontinuities in parts made by ferromagnetic materials. Magnetic particle testing is governed by the laws of magnetism and is therefore restricted to inspection of materials that can support magnetic flux lines. For example, ferromagnetic materials including iron, nickel, cobalt and their alloys can be tested using magnetic particle testing. The magnetic particle testing is used for materials that can be easily magnetized, and it cannot be used for non-ferromagnetic materials like stainless steel and gold, antimony, bismuth, in which the defect is tough to be identified through this method. Only those materials classified as ferromagnetic materials can be inspected effectively using magnetic particle testing. The principle behind magnetic particle testing: in a magnetized material, surface and subsurface discontinuities like cracks, seams cause a break in the magnetic uniformity, or under sudden change in the permeability, these cracks in magnetic uniformity set up a minute magnetic poles and leakage flux paths which attract fine magnetic powder particle to the discontinuities, forming a reliable visual indication of the discontinuity. In the magnetic material, there will be magnetic field in and around the material, and the magnetic lines of force exits the magnet from north pole and enters from the south pole. When the magnetic field encounters a break in the magnetic field due to crack or induction inclusion, the magnetic field disturbances are produced. This variation in the magnetic field can be identified by sparkling magnetic materials on the surface of the part to be inspected. The material will be attracted at the edge of the crack. Critical investigation will reveal the pattern of the defect in the surface or subsurface of the part. Advantages. Some of the advantages of magnetic particle testing is high sensitivity, and complex parts can be inspected rapidly. Surface preparation is not required. It is portable method, and it can reveal both surface and subsurface flaws. Large and small objects can be examined using this method. It is a low cost method and the equipment are relatively inexpensive. Limitations: only ferromagnetic materials can be tested using this method. Proper alignment of magnetic field is important in achieving good result, and it cannot detect defects at or near surfaces. It is applicable only for subsurface flaws. High current source is required. If any painting of non-magnetic nature is covering the defect, then the sensitivity of magnetic particle testing may be affected. Talking about the applications of magnetic particle testing, it is useful to inspect fans, blowers, and thermal power plants, inspection of weld cracks, inspection of connecting rods, underwater inspection like offshore inspection, pipeline inspection, ship structure inspection, etc. There are two types of magnetic particle inspection technique based on the magnetic particles used. Number one is the dry particle inspection, and then is the wet particle inspection. In dry particle inspection, dry powders are applied on the surface of the test object, and then the item is magnetized. Dry particle inspection is well suited for inspections conducted on rough surfaces. So the steps involved in dry particle magnetic particle inspection are cleaning the surface or surface preparation, demagnetization, magnetization, followed by application of dry magnetic material, then blowing off of excess powder, followed by terminating the magnetizing force and inspection or interpretation. The advantage of dry particle testing is that the defects that are near surface can be easily detected compared to wet particle testing, and it is highly suitable for objects which have portable equipment for local magnetization. Then comes the wet particle inspection. Wet particle inspection technique, the particle are applied while they are suspended in a liquid carrier. This technique is commonly performed using stationary or wet horizontal inspection unit. So the steps involved in wet particle inspection are cleaning or surface preparation, demagnetization, application of suspended magnetic particle, followed by magnetization and interpretation. The advantage of wet particle inspection is that surface of the part can be easily covered by the particle suspension. Liquid carrier provides mobility to the particles. Best results are possible in reduction of very small cracks on smooth surfaces. Talking about the equipments used for magnetic particle testing, the main equipments may be categorized as magnetization equipment, portable power supply, and lighting equipment. Under magnetization equipment, they can be broadly classified based on the portability as portable magnetization equipment and stationary magnetization equipment. Portable magnetization equipment are suitable for inspection in the field. Typical portable magnetization equipment are permanent magnet, electromagnetic yokes, prods, and portable coils. Permanent magnets can be bar magnets, horseshoe magnets, which are source of magnetism. The permanent magnets can be made small enough to fit into tight areas where electromagnets might not fit. Electromagnetic yokes. The high portability can be achieved by using electromagnetic yokes. This unit can be used with AC and is also available in DC from a battery pack. This type of magnet generates very strong magnetic field in a local area where the poles of the magnet touch the part being inspected. About prods are handheld electrodes that can be pressed against the surface of the component to be tested. Here you can see the pictorial representation of permanent magnets, electromagnetic yokes, prods, and portable coils. So these prods are handled electrodes. They're typically made of copper and have an insulated handle to protect the operator. Then portable coils, they are used to establish a longitudinal magnetic field within a component. The magnetic field is parallel to the axis of the component. The coil are normally will be having 3 to 5 turns of copper cable within the mount frame. The control switch is used to energize the coil. Then we have stationary magnetic equipment. In stationary magnetic particle inspection equipment is designed for use in laboratory or production environment. The most common stationary system is a wet horizontal unit. This unit is provided with fixed headstock and a sliding tailstock. Then we have the portable power supply. Portable power supply equipments like prods, coils, cables need supply to energize it during inspection of the component. The power supply are available in different sizes according to the requirement. Small power supplies generally provide up to 1500 ampere current. Then talking about the lighting equipment, magnetic particle inspection is basically a visual inspection method after magnetizing and applying metal powder. Therefore, sufficient lighting is important to identify the defect. The lighting equipment requirement are like lighting for visible colored particles and lighting for fluorescent particles. In case of visible colored particles, daylight is enough. Natural daylights may change from time to time. So use of artificial lighting is highly recommended for good results. In case of fluorescent particles, we can go for strong ultraviolet light. Mercury vapor lamp with filters is used to fluorescent the particles, so to make the changes visible. Talking about the equipments used to determine the magnetic field strength and direction. To check the adequacy of field strength and direction, various equipments are used. Some of the main equipments used to determine these parameters are Hall effect or gas meter, pi gauge, quantitative quality indicator QQI, and slotted strips. Gas meter is generally used to measure the tangential field strength on the surface of the part. Most common Hall effect meters are transverse probe and axial probe. Transverse probe have Hall effect element mounted on a thin flat stem, and they are used to make measurement between two magnetic poles. Axial Hall effect probes have the sensing element mounted such that the magnetic flux in the direction of the long axis of the probe is measured. The pi gauge is octagonally shaped disc made by highly permeable low certain speed segments joined together by brassing. One side of the octagonal flat plate is plated with copper to hide the joint lines. The gauge is placed on the test specimen during magnetization. with its copper face up. The particle is applied on the face and the orientation of the field is displayed by the indication produced in the joint lines. The quantitative quality indicator is an artificial flat standard used for calibration of magnetic field strength direction. It is made up of thin steel strip with a thickness of 0.05 to 0.1 millimeter, and specific patterns are etched on the surface. To ensure intimate contact with the part being inspected, the QQI is taped or glued with the etched side down. By spreading magnetic particle over the component, the particle get adhered to the part surface, provide information about the field direction. Slotted strips, also called as Burma-Castrol strips, are pieces of highly permeable ferromagnetic materials with slots of different widths that are placed on the object and magnetic field is established. The slotted strips provide the idea of the magnetic field strength. These strips are used with wet or dry method. So with this we come to the end of this video. Thank you for patiently listening.